let's talk about the limit definition of a definite integral. Now, you should remember the limit definition of a derivative. Or if you've forgotten it, this is a good time to remember it. Limit definition of a derivative. That was the one where we had this. And then up here we had that one. Oops, I don't know why I put an H there. Yes. So that was our limit definition of a derivative. If you do not remember that at all, we will go over it during our review unit before you take the AP test. But I would also suggest that you go back to page 55 in your notes, and it should also be written right there. It might jog your memory a little bit. So for this lesson, we're talking about the limit definition of a derivative. This right here. Now, you might look at this and go, Mrs. Johnson, I have no idea what this means, and that's okay. Gary actually specifically did these problems with us over the summer camp, and he said that you guys in AB don't really need to know this very specifically. He said these examples right here are the only kind of questions you might be asked about this on the AP test. So here was the decision I made. Instead of spending a 15-minute video talking exactly what all of this means, I'm just going to go over it kind of generally, and then if you would like to know what this means more specifically, you can come and talk to me individually. So, just so you know, what we've done so far is we know that if we take this curve and I cut it up into subdivisions and I do trapezoids, that it's a good approximation for this curve. So this little thing right here, that just means sum. It's basically just saying add all the trapezoids together, which is what we've been doing in all these problems. Oops, sorry, I lied. It's add all rectangles. We're going back to rectangles for this. Now, something that I want you to notice from this graph. Can you see that the more intervals I get, the more accurate it's going to be when I add all of them together? That is this limit as n goes to infinity. So that is saying my width of my intervals is getting smaller and smaller and smaller. And then that is, as those get smaller and smaller and smaller, infinitely smaller even, that's how we get the area under this curve. So limit as n goes to infinity, as we add all the rectangles together. This is the width of your rectangle. Remember, this B is your upper limit, A is your lower limit. So you're basically saying this is B, this is A, and to get the width of each of these, I do B minus A and divide by how many rectangles I have. That's that N, how many rectangles I have. And that's the width of each of those rectangles. This is the height of your rectangles, where you're taking, this is your X value, and plugging it into the function, and then that gives you your Y value or your height. So that's kind of what it means generally. I'm not going to go into it specifically anymore. I just want to talk about each of these problems and discuss how you do them. Now, one other note really quickly, there's a typo in your workbook. This says we will focus on right Riemann sums. A left Riemann sum would be the same, except it would be k equals 0. Not k equals 1. So the only difference is you'd have 0 here and n minus 1 there. So that's a left Riemann sum. We're focusing on right though. Okay, let's go back to this example. there are 3 things that you need to be able to do to translate this into this. So let's go over those 3 things. The first one is finding this width. So this b minus a. So b is your upper limit, 4 minus, here, let's see. Let's label this a little better. Step 1 is the width, b minus a over n. So this is going to be 4 minus 1 over n. N stays, because remember, n is how many rectangles we have, and we don't know. We actually want infinity rectangles, so we're not going to mess with that n. So that's step 1. Step 2 is looking at what is a, so that I can put that right there. So step 2 is what is a. Well, we know a is the lower limit, so a equals 1. And then step 3 is what is my function. So my function on the integral is on the inside, so this one is x to the 5th. So now that I have those 3 things, I can do this. And I'm going to put in black everything that we don't change. Stays the same. Oops. Ah. And let's see. We're going to have parentheses. We're going to have a K and a plus. This over n stays, and this over n stays. Okay, this all stays the same. Now, let's do right here, that is your width. So whatever we found over here from our width, so we got 4 minus 1, that's what goes there. That's step 1, find your width. Now you'll also notice the width goes there. If you look right here, b minus a goes on top of n again. So the width also goes right there. Okay, next one is your a goes in front of your k. So we know a equals 1. So far so good. Second, or I should say third, the last thing is our function. So essentially, this whole bit right here, I want to go inside my function. So my function takes things and does them to the 5th power. So I'm going to take this thing and do it to the 5th power, because that's what my function does. Takes things to the 5th power. And that right there is your answer. Okay, let's try going the other direction. Here's this. We need to do the same 3 steps to be able to write it like this. That's what I want. Oops. So step 1 is to look at my width. So b minus a over n. Well, I know that is my width. So I'm going to say b minus a over n equals pi over n. So essentially what's that saying is if I subtract these 2 things, they should be pi width apart. That's what this is talking about. So we're going to put that on the back burner and move to step 2. Step 2, what is a? Well, remember a is always in front of your k. So a is going to be pi halves. So that right there is going to be my lower limit. And remember, these need to be pi width apart. So I am going to add my width to get to my upper limit. There we go. Last one is the function. So we're saying, what is all of this being plugged into? Well, it looks like this whole complicated mess is getting plugged into sine. So our function is going to be sine. So that, give myself a little more room, is what I'm going to write there. And that is your answer. So that is the limit definition of our integral, or our area under the curve. If this made 0 sense to you, it's okay. Just memorize these, because Gary said this is the only kind of question the AP test would ask you to do using this stuff.